Hello everyone, uh, welcome to MGF1106. Before we start, I just want to introduce myself. I'm Professor Nguyen. You can call me Mr. Nguyen or Professor Nguyen. Um, this course is MGF1106. It's for a liberal arts student, and for those who are taking the course, so you know exactly what kind of math and what this course about, and what we have to cover in this course. For student who's really new to this course, I will let you know what kind of math we cover in this semester. So MGF 1106 is mathematics for liberal arts student, and the purpose of this course is it is to design to train your logical thinking and logical thinking skill and problem solving skill, as well as a quantitative reasoning skill. So in this course, we're going to cover um, 5 different branches of mathematics. So let me just go ahead and list them down so that you know the overall idea what we have to do and what kind of math we have to do in this course. Okay, so I'm gonna put over here. This is MGF 1106. Okay, and five different branches of mathematics we cover in this course. The first thing we cover is a set. Yeah, we're gonna cover this theory. I don't want to use that term because we're gonna do as a very standard basic one, concept, set concept. We're not gonna do something crazy. So we're gonna cover this concept during the first 2 or 3 weeks of the semester. So this is one of the branch in mathematics. It's very important branch. Is I can consider this as a foundation of mathematics, of modern mathematics. Then the second branch of mathematics we cover is logic. I see that we have to learn logic, right? That's the purpose of this course. We have the course is to use to train your logical thinking skill and critical thinking skill, right? And then we're gonna talk about uh, the third branch of analytic squad. This is very easy. This is considered as just a concept. It's not really the home branches of the metric system. So I don't know if you guys still recall, but we already learned this back in the day. Right? Maybe when you in middle school and high school. So we're gonna go ahead and kind of redo that again. Then the last two topics is probability. Oh, hold on, this is geometry. We have to do geometry. Geometry. So geometry is a different branch of mathematics. We require you to visualize and to be able to see the picture, right? Then we're gonna talk about the last two branch mathematics, probability. Okay, probability. And then finally, we're going to talk about a statistic. Okay, statistic. Now, I have to say that these two branches of mathematics over here is kind of related to each other very, very much. Um, Statistic is we collect data, we analyze data, and we use those data. After we analyze it, we use data to predict the future. It's the same thing. Uh, as the same thing as the probability uh, um, we used to predict the future event, right, based on some information. So this kind of mathematics is very related to each other. Okay, so well, I have to say that there are 6 topics we have to cover, but I mean this is a metric system is very easy. So we just cover basically 5 branches of mathematics. So maybe you see geometry. So some of you already know it in high school, right? Maybe some of you already know a little bit of statistics in high school. Also, logic. Maybe this is very new to all of you. So we're gonna in this concept right here, when we reach to this concept, this section, this chapter, then we learn some basic concept in logical thinking. Very important. Now, maybe some student was like, why we need to learn all this? And my major is liberal art major. There's nothing to do with this. Well, the purpose of mathematics is to train your logical thinking, to train you to be able to reason. Okay, isn't it? That's what mathematics about. Sometimes you work outside. Of course, you're not gonna see any of this concept. Like for example, like set, or probability. Maybe probability. Yeah, maybe. Because if you or statistic, maybe you work for the bank. But I mean, majority of this topic here, you never touch it, when you work it, after you graduate. So then why we have to learn all this? We just use mathematics to train your logical thinking, critical thinking skill. That is the most important part. Okay, whatever you do, it doesn't matter is it related to math or not related to math. You must have a critical thinking skill. You go, for example, like you buy a new house, and you see that if you have enough money, or even you buy a new car, and you see that the interest rate, so all of them is the logical thinking skill. Okay, you must be able to think. That's the most important part in this course. Okay. Okay, so let me start. So the course is actually the course is just a series. It includes a series of the video, and I'm gonna split into the whole course. I'm gonna split into many videos. Each video talking about a certain concept in one of these mathematics concept, in one of the mathematics branches over here. Okay. Okay, so the first branch of mathematics I want to talk about today in this video is set. So let's talk about set. Now, before we talk about set, um, back in the day, I don't know if you remember the first time you learned numbers, right? You learn different type of number, decimal number, fraction, integer, blah blah blah. And you see that mathematician they try to categorize number into group, right? Or into, I can say this, they categorize those number into collection number of different type of number. And that collection number we call a set. Okay, so in the first part of our lecture today, I would like to talk about a set. Okay, the definition of a set. Definition set. Okay, so what is set? As I told you, the mathematician categorize number into group, into collection. So basically, set is just a collection of items. So a collection. So set is the collection of items. Okay, okay, and this item here, our all item, we call that elements. Okay, called element. Okay. So set is collection of item, and this item is all item is called element. So we so for example, we have a set of number, then the number an element of that set. And we have so many different set, and we can use some symbol to represent set. If there's some different some method to to write a set. Okay. And so the set notation we can have is it can be written as this. For example, I can say that we have a set A. Okay, so we're gonna put set A, and set A does include a bunch of items. Okay, I don't know what item, but I can write the set A is in a with the equal. Okay, and I can use the curly bracket like this, and in this curly bracket over here we have different items. So for example, we have a set of furniture. Then we have different type of furniture over here. We might have then we have a set of integer. Then we have different type of integer. We can have a positive integer or negative integer, something like that. Okay, and the set it can be well defined or it's not well defined or poor defined. A set can be if it is well defined. Okay, well defined set. Okay. Uh, uh, well-defined set is a set which element is defined clearly, okay, and it clearly determined. For example, I can say so over here well-defined set. I can say that it clearly determined. It's not vague. For example, I can say the set of positive integer. So we know the integer is positive. And some is if the set is not well defined, then it will be poor defined. I mean, and it's very hard to determine the element of the set. For example, I can say the set um, of good food. Yeah, I don't know what does it mean good food or good dishes. Well, the food is good or not depend on the people who taste it sometime. Or for example, Asian food, some of you don't like it. Or maybe some Italian food or some Asian don't like. If a set of good food, then it's not well defined, right? Because we don't know and we don't know exactly the definition of being good food over there. So it depends on the person. So those set is not defined. It's not well defined. Okay. Now let me give you the first example of the very well defined set over here. For example, I have a set A. Okay. So I'm gonna put a set notation. This is set notation. Okay. Set notation. Okay, this set notation. Um, so over here, for example, I have a set over here, and then I have set over here includes some number. For example, I include some natural number over here. For example, I have put 2, 1, or 4, 5. So this is a very well-defined set. Okay, this set over here have 4 elements. We have 4 elements, and the number of elements in this set we call that a cardinality. Cardinality. Excuse me. Um, so I can say over here the cardinality of set A is 4. Okay, so cardinality. Okay, so this is cardinal number. Okay, so cardinal number is just the number of element in that set. Okay, so in this we have, you see the element. So we have set A over here, we have 4 elements. So the cardinality is 4 because there are 4 elements in the set. Or I can have let me create another set. A set B over here. For example, a set B is a set. Okay, I can write over here. Set B is a set. Okay, of natural number. okay, of natural number, or a positive integer. Or you can say a set of natural number. Okay, uh, okay, less than less than less than 6. Okay, so you can create a set B like this, right? Natural numbers 1, 2, 3, 4, 5. There you go. So over here the set B over here have 5 elements. So the cardinality of set B will be 5. Okay, we call the number of element of B will be 5. Hey, here you go. So it's very simple like that. Okay. Or I can uh, so you see that over here we can write a set with the curly bracket, or and with the equal sign like this. Some set we can write using the set builder notation. So we can we can use set builder notation to write a set. I'm sure that some of you already heard this term before. So how you write set builder notation? Okay, for example, I can say like this. I can say how about this? I can say a set C over here. Okay, set C is so I'm gonna write in set builder notation. Okay, curly bracket, and I'm gonna put the x variable x over here, and I have a bar like that, and x over here, x is a month, is month. Okay, this is month that begin. Okay, that begins with letter M. Okay, so you know the month that's beginning with letter M, which is May and March, right? But I instead of put C equal, so I can put C equal May and March. You can put it like this, or you can use this set builder notation. So this is the set builder notation over here. So we have a variable x, and we have a curly bracket like that. Or I can have a set builder. I can give you another example of set builder notation. So this is example 1, 2. This is 1. Okay, example 2 right here. Okay, how about this? The set over here is set D, and the variable x. Okay, they always have variable, and x is a positive, odd in. Okay, positive. X is positive, and odd, positive odd. So I'm not gonna write this positive. Oh, that's weird. I cannot use this. I don't know why I cannot erase this. Oh, there you go. Positive. Oops. Positive. Odd number. Okay. Less than 10. There you go. This is the way you write the set builder notation for the set. Okay, it's builder notation for the set. And you can, of course, you can use the first method to write the curly bracket, and you just go ahead and list all the positive odd number. Let's say, for example, like you list them out. You can list D equal to positive odd, right? So it'll be 1, 3, 5, 7, and 9. There you go. So you can use either way to write a set. Okay. So over here, the set over here is the number of element over here is also 5. The cardinal Cardinal cardinality. I'm sorry. Cardinality is 5 because it contains 5 elements over here. Okay. Now what if the set it does not contain any element? What happened to the set? What is going on if it does not contain any element? Okay. What happened? You know, and what is that set called? So on the second part of the our lecture video over here, I will talk about some property of the set. Property of set. Okay, property of set. Okay. Okay. So if it is set, okay, if it is set, if it is set, it does not contain, okay, if it is said it does not contain any element, then we call that is empty set. Okay, or sometimes we call that there's another name we call the non-set. So this set is the no element inside. So if it does not contain any element, then we call that empty set. Okay, and empty set we can write like this. For example, I can call this empty set is set A, and here are the curly bracket, but I don't put anything over there. Or I can put set A is equal to, and there's a symbol like this for the empty set. It means it does not contain any element over there. Okay. Now, what if they have? What do we have? Two sets. Okay, and the cardinality of those two sets are equal to each other. What if I have set A, they have 5 elements, and also set B have 5 elements. Then if they have the same cardinality number, then we call that equivalent set. Okay, equivalent set. Okay, equivalent set. So equivalent set is the set, the cardinality the set. So the first set A has 5 elements, also set B has 5 elements, so it's the same. Then we call the equivalent set. Okay, for example, I'm gonna write example. For example, I have a set A over here, and set A over here it contains, let's say, let me see. What if set A over here have -3, -2, 1, 5, and 9. Okay, so the cardinality for set A is 5 element, and what if set B have -1, 0, 1, 2, 3. Okay, so you see the element of set A is very different. Some of them share same common, but I mean they are different. Okay, however, the number of element and set A and B the same. So that's why I can say that set A is equivalent. Okay, set A is equivalent, okay, to set B because cardinality of A is the same as cardinality of B. Okay, so it's an equivalent set. Now, what if I have two sets? Okay, I also have two sets, but the element is the same. So all elements is same common. So if the all elements is same common between two sets, then we call the equal set. Equal set. Okay, so equal set. So if so set A equal to set B if set A and set B have the same element. Have the same element. And of course the cardinality will be the same. So the equal set is actually equivalent set. However, they also have the same element. For example, I have it over here. Oh, I'm sorry. Whatever, I have it here. Let me write it in this color. Whatever have set A here, and I have 2, 3, and 4, and set B is 3, 2, and 4. Okay, doesn't matter. I just change the position, but you see the only element is the same. So I can say, so from here I can say that set A equal to set B. Okay. All right. Now another property. I mean, there's a lot of property, but in this course, we just cover some important, especially in the first video over here. We just cover some. Now, this property is related to the empty set. Let me see. This is covered over here, or maybe next section. Yeah, I think we can talk about empty set more in this the second video. Now, the next one I want to talk about is universal sets. Universal set. So what is universal set? So a universal set is that we can notate it with letter U. Okay, this letter U. This is a set. It is a set. It contains all elements for a specific discussion of the specific question. So contain letter U containing all element in a specific discussion, or specific question. So in the question, they have a certain number of elements. So universal set is cover all of them. It means all the element in that question will belong to universal set. And if it belong to the universal set, then we can write like this. We can use two different symbol here to write when an element belong to a set. Sort of you can use this symbol here. I think I'm gonna use the different color. This color is not good. Okay, so you can use this symbol here. Oh no, this color is even more terrible. I think I can use this, but this increase them. Okay, so there's two symbols. You can use this symbol like this. Okay, and it means belong to. Okay, or you can use the symbol like that also, but with a dash line over there. So this is not belong to. Okay, does not belong to. Okay, no. So two different symbol. For example, I can write like this. Example. I don't know this color is good or not. Maybe some of you can see this color, maybe some not. So maybe next time I try not to use this color. For example, I have I look at this set right, set a 2, 3, 4, right? So I can write 2, okay, belong to A. Okay, 2 belong to set A. Okay, 2 belong to set A. And the set 8 over here has only 2, 3, and 4, so I can write 5 does not belong to set A. I'm referring to this set A, okay? Okay, this one is set A. So you can use this symbol over here to write um, an element when it is belong or not belong um, to a set. Okay. Now, at the beginning of video, when I talk about the set, when we talk about natural number, you see that there's a lot of number. Okay, there's a lot of number over there. Okay, and natural number actually um, we call that countable infinite set. This term over here is kind of I don't want to use it, but I want to touch that. So because there's some set that contains so many elements. uh, there's some set that contain a finite number of elements. If it contains finite number of elements and it can count it and you can finish the counting, then we can call the finite set. Finite set. So finite set is a set that we can count and we can finish counting. Remember that, okay? So finite set is the set we can count and we can finish counting. So far, all the example I give you is this finite set. Yeah, but mathematically, the definition of finite set is like this. Uh, if a set A, okay, I'm gonna write over here. If a set A is called a finite, is finite. Okay. If the set A is finite, if the cardinality of A is 0. Okay. So actually the empty set, right? Because there's no element in that set. So the cardinality is 0. So actually in this case, what I mean over here is the empty set is a finite set. Or the cardinality of A is a natural number. Natural number. For example, in this case, okay. All right, how about this? Let me refer to this again. Let me refer to this, okay. Or let me give you another example. I think it's easier with another example. Okay. For example, I have something. Oops, I cannot erase. What if I have this? Example. I want to create another set. Okay, what if I have set A over here? And set A over here is a collection of some luxury car. What if I have over here? I have a Bugatti. Okay, it's a very luxury car. Then I have a Lamborghini. Okay, Lamborghini. I have how about I'm gonna put over here is McLaren. Okay, I have McLaren. Okay, then I have what else? I have Bentley. Okay, okay, Bentley is a very beautiful car too. Then I have let me see, Bugatti, Lamborghini. Oh, I have Ferrari. Okay, Ferrari. So you see over here, the cardinality of A is 5. And 5 is a natural number. Right? 5 is a natural number. So that's why I can say that set A is finite. Set A is finite. Okay? Because we can count it. We can count and we can finish counting. So this is the first element, count the second one, the third one, the second and fourth one, and the fifth one. So that is fine. Now, then what happened? Um, what happened when we have a set that contain infinitely many number? Uh, then we can say that's an infinite set. So here I'm going to put infinite. Okay, infinite set. Infinite set. So infinite set is a set we can not finish counting. Okay. Um, for example, uh, I have a set. I have a set of a natural number. We can count it, but we cannot finish counting. You know, natural number is 1, 2, 3, 4, 5, 6, 7, 8, and so on and so on. So we can count it, but we cannot finish counting. So that's what we call that a countable infinite set. I don't want to talk too much about this, okay? Especially more theoretical regarding to finite set and infinite set. Basically, later on, you will learn a mathematical definition. This is also definition, but it's not theoretical. Later on, if I have change, then when we talk about the theoretical definition of infinite set and finite set. But at this moment, I don't want to discuss too much about it. So you just need to know that the finite set we can count it when we finish counting, but the infinite set we cannot finish counting. We can count, but we cannot finish counting. Uh, the reason we can count and we cannot finish counting is the one of example here, the set of natural numbers. So that's why later on this a set of natural number we call that countable infinite set. Okay, and there's some set we call that uncountable infinite set. But again, I don't want to talk too much about this. So basically, that's all you need to know for the first section. Okay, so let's see if we missed any information here. So look like we already we cover all the basic definition and some property of the set already. Let's do maybe a couple more. Let's see if we can do some example right over here. We can do that. Let me see. Oh, I forgot about mentioning this terminology over here. So we know that, okay, so we know that when we write like this, we use we call it set builder notation. So if we write like this, so actually in some textbook, I just want to add some information. Maybe in the textbook we did not mention about that, but just in case, um, when we write a set with a capital letter and a curly bracket like this, so this one we call that the roast. We call it um, roster method. So roster method is just you list them out without without a capital A. So for example, I can say like this. I'm gonna write over here. So example, this is just some practice over here. I'm gonna put some practice over here. Problem here. Okay. Okay. What if I have um I have a set builder notation like this. A set A and set A is set over here. All the element it belong to natural number and and the condition that's all the natural number over here must be less than or must be between 50 and 200. Okay, so this is the set builder notation. Then we can write the roster method. So I'm gonna just go ahead and write different color over here so that you know this is called roster method. So roster method is the same as the set notation, except for the fact that they throw away the capital A, right, the name right here. So we just write of so there's no 50 over here. This is hard to. So this is between 50 and 200. So we just go ahead. I don't know why I cannot erase this. All right. So this will be for between 50 and 200. So it will be 51. So it will be 51, 52, 53, and so on. Then up to 200. There you go. This is called a roster method. Some textbook they have this name, so just in case you see that in your My Math lab when you do homework. Okay. All right. So I think that's is all information I want to provide for the first video. This is section 2.1. So okay. So this is section 2.1. Okay. Now, I'm gonna stop this video here, and on section 2.2, I will be talking more about set, some new definition, because you see that the set does contain many elements. Okay. Then what if we just grab some element and let's create another set inside the set? Then let's see the new set what we call. Okay. So that will be in section 2.2. Okay, so I'm gonna stop over here and I'll see you guys next time. Bye bye.